All right, let's jump right in. Today we're exploring a really cool idea called quantum nudges. We're going to see how the science of why we make certain choices connects, believe it or not, to the strange and wonderful world of quantum mechanics. It's all about the physics of choice.
So it all starts with a question that, let's be honest, sounds a little crazy, right? What in the world could the rules for tiny subatomic particles have to do with you choosing the stairs over the escalator or deciding what to have for lunch? I mean, they seem like completely separate universes. But as you're about to see, there's a surprisingly powerful connection.
So how do we bridge that gap? Well, the key that unlocks this whole thing is a framework called nudges. Now, this isn't just a bunch of vague ideas. Think of it as a super precise design checklist, a real blueprint for helping build better choices. And we're going to break down each step using the language of quantum physics.
First up, we've got N for incentives. And yep, that N is silent, just go with it. Before you can influence any choice, you have to understand what's really driving someone. What's their motivation? Do they actually want to change, but something's in their way? Or are they totally fine right where they are? It's that first, crucial step of figuring things out.
And this is where our first quantum metaphor clicks right into place. In physics, you have this idea of a potential valley. A little particle sitting in that valley isn't going anywhere unless it gets a push of energy to get it over the hill. It's the exact same for people. We need the right motivational energy, the right incentive to get us to change our state.
Okay, next up in nudges, we have U for understand mapping. This is all about picturing the actual journey of a decision. You literally have to map out every single step a person takes so you can find those exact spots where they get confused or overwhelmed or just give up. You're looking for the bottlenecks.
And the parallel to quantum physics here, it's awesome. Think of it like a quantum circuit diagram. Physicists use these to trace a particle's journey from point A to point B, and they can pinpoint exactly where that particle might scatter, basically get lost, or decay, which is pretty much the particle version of throwing in the towel. So mapping a choice is just like drawing the circuit for a human decision.
Now we get to D for defaults, and guys, this one is a huge deal. A default is simply the choice that gets made if you do absolutely nothing. It taps into our natural inertia. So by making the best option the default, you make the right choice the easiest choice.
And the physics connection for this one is just perfect. It's the idea of the ground state. See, in nature, things will always settle into their lowest possible energy state if you just leave them alone. It takes zero effort. A really well-designed default just puts the best outcome in that effortless ground state.
All right, on to the G in nudges. Give feedback. For a new habit to actually stick, people need clear and, this is key, immediate information about what just happened. Did it work? Was that a good move? That little loop is what turns a one-time action into something we do automatically.
So what's the quantum version of this? It's something called observation. An unobserved particle can be in a weird, fuzzy state of many possibilities at once. But the second you look at it, you observe it, it snaps into one definite state. Well, getting frequent feedback works just like that observation, stopping us from sliding back into indecision and locking in a new, positive behavior.
Next up, E for expect error. And this is all about being realistic, right? People are human, we make mistakes, we forget things, we get distracted. A smart system knows this is going to happen and is built to be forgiving, so that one little slip-up doesn't cause a total disaster.
This is absolutely crucial in something like quantum computing. Those systems are incredibly sensitive to tiny errors or noise. So engineers build in these clever error correction codes. They're basically safeguards to make sure one little hiccup doesn't bring the whole system crashing down. We need to build those same kinds of safeguards for people.
And finally, we have S for structure complex choices. We've all been there, right? Staring at a menu with 100 options and your brain just freezes. This last principle is all about cutting through that noise, about organizing and simplifying the options so the best path forward becomes obvious.
And I gotta say, the quantum metaphor for this one is just so elegant. It's called the waveguide. If a particle has way too many paths it could take, it all gets jumbled up into a confusing mess. A waveguide is a structure that neatly channels that particle, getting rid of all the confusing paths and guiding it right where it needs to go. That's exactly what good choice design does.
Okay, so that's the theory, the whole nudges blueprint translated into the wild world of physics. But you're probably thinking, does this stuff actually work in the real world? Oh, you bet it does. Let's look at a few classic real-world examples that show just how powerful these ideas are.
Let's kick things off with a really famous one, organ donation. I mean, just look at the difference here.
On one side, you have countries where you have to actively sign up to be a donor, you have to opt in, and the rates are super low. Then you have countries where you're automatically a donor unless you say no, you have to opt out, and boom, the rates are through the roof.
So what's going on? It's not that people in one country are suddenly way more generous. It's all about the design. This is our ground state metaphor in action. They literally set the easiest, do-nothing option, the path of least resistance, to consent. No force, no laws, just smarter architecture.
Or check this one out. A school wants kids to eat healthier. What do? Not lectures, not posters. Nope. They just redesigned the lunch tray. They structured the choices by creating these specific compartments for fruits and veggies. And they expected error. An empty slot just feels wrong, so it nudges you not to forget the healthy stuff. It's basically a physical waveguide for a better lunch.
Okay, this one is just plain fun. The piano stairs experiment in Stockholm. The problem? Everybody's taking the escalator. The solution? They turn the stairs into a giant working piano. This added a fantastic incentive, fun, to a boring task. And you got that immediate rewarding feedback with every step, a musical note. The result? People were happily nudged out of the low-energy ground state of riding the escalator.
So, when you put all these examples together, what's the big picture? They show us something really profound about how we work. The environments we're in, the systems we use every day, they aren't neutral, not at all. They are designed, and that design is shaping our choices, whether we realize it or not.
So the big takeaway, the thing to really remember, is this. Influencing behavior for the better isn't about forcing people or telling them what to do. It's about being a thoughtful choice architect. It's about designing an environment where the best decisions also happen to be the easiest ones. And there's this quote from the source material that just nails it for me. It says, "The nudges checklist is quantum programming for a happier future. It perfectly reframes the whole idea. This isn't just some marketing trick, it's a powerful, precise way to, in a very real sense, program a better world." And that's what I want to leave you with. These ideas aren't just for governments or big companies. You can be a choice architect in your own life, for your family, in your community. So the question is, where in your world can you design a better choice?